problem and then we'll talk through it. The length of a school bus is 12.6 meters. If 9 school buses park end to end with 2 meters between each one, what's the total length from the front of the first bus to the end of the last bus? Now you have a tape diagram, correct?
I already know what to do.
Okay, so on this tape diagram, I made it pretty long, didn't I?
Yeah.
The reason it's so long is because I'm going to put 9 school buses there. Okay? So let's start out with 9 school buses. Now, a lot of kids will look at this problem and think, oh, this is easy. I'm going to multiply 12 times 9 and 2 times 9, add those together, and I'll get my answer.
No, you have to.
Okay, but let's wait and see if that's going to be right. Okay? So let's start with 9 school buses. So how many boxes will you need?
8.
You will need 9 boxes for 9 school buses. And each school bus
Oh, yeah.
is 12.6 meters. Just write it in the first box for now. Okay? What's the next part of the problem, I say, is start with if 9 school buses.
If 9 school buses park end to end with 2 meters between each one.
Okay, stop. 2 meters between each one. So how could I show 2 meters between each one? Any ideas?
You add 4 boxes.
I'm going to have to add more boxes, but they're going to be little, aren't they? This is just going to be like a space between the school buses. And if you can't fit 2 in each little space, you can always write it at the bottom. You can go ahead and write 12.6, but you don't have to. Where does the question mark go, boys and girls?
At the top.
At the top. The total length of the 9 school buses with 2 meters in between each one. So we'll have 2 multiplication problems, okay? And let's go ahead and do the school buses first. So what's my multiplication problem for school buses, Daniela? Not the meters in between, just the school buses.
12.6
12.6
times 9.
times 9. Now I'm going to do whoops, that's 7. I'm going to do standard algorithm, okay? What's my typical strategy for dealing with the decimal? Riley?
You take the decimal.
I'm going to take the decimal out. So instead of 12.6, I'll write 126. What's my place value?
Tenths.
Tenths. Take that times 9. Okay, go ahead and multiply that out. Just go ahead and multiply it out. What label do I need on the bottom of this?
Tenths.
Tenths. So, when I write my answer, Ari, where will I place the decimal? Between what 2 numbers?
1 and 3.
That would mean that it's only 11 feet, or 11 meters.
4?
Let's see if the 3 and 4 makes sense.
I think
I have a tenths place here and a tenths place here. Is that correct?
Yes.
Yes. Okay. So sometimes you have to go back to remember, use logic. Does it make sense for it to your answer to be 11 when you started out with 12 meters per bus? Okay. And then always you can use that underlining strategy. What do I need to add to this 113.4 though to get my answer?
Times 9.
2 times 9? Let's see.
No,
18.
2 times 7. 2
What?
times 7.
Because Keegan's idea first, then Hunter's.
No, why don't you count your twos?
Look at it.
Huh?
Why don't you count your twos? Do it on your paper.
That's 18. And then 18 plus.
It's not. Did you count your twos?
7 remainder 1.
1, 2, 3, 4, 5, 6, 7, 8 times 2.
Oh, 8 times
8 times 2 equals 16. Now here's what they want you to do. They want you to mess up when you add these together. So over to the side, I want you to do 113.4 plus 16. Where do I write my 6?
And the
Under 3.
Under the 3, in the ones place.
Can we add a 0 to the end and put the
You
dash?
sure can.
Yay.
So the total length from the beginning of the first bus to the end of the last bus is what?
129.4.
Meters, okay? All right.
Do the bottom problem by ourselves.
No, we're going to talk through it because it's a little different. How is this problem different from the ones we've been doing?
Because it
has
has
three-digit
three
numbers.
digits. It has 3 digit on the top and 3 digit on the bottom.
Okay, so let's break these apart. I don't have a lot of room to do it on my paper, so I'm going to do it up here. 500 plus 20 plus 4 and 100 plus 30 plus 6. Which one goes on the top, Daniela?
500 to 24.
Okay. And Xavier, what do you think? When I do 136 on the side, what number comes at the top of those?
100?
No.
No.
Look at your other one.
I mean,
Make sure you,
630, 100.
good. Make sure you put the largest number on the bottom. Okay. So now I want to highlight these and then we're going to talk about it before we do it. So this means that I am going to have 3 partial products now. And what that means is I'm going to do 3 multiplication problems. The first multiplication problem I'm going to do is 524 times 6. The second multiplication problem I'm going to do is 524 times 30.
30.
The third multiplication problem I'm going to...
Marco's on the side.
Oh.
Is there last?
is 100. See my 6, my 30, and my 100 on the side of the area model. So when I get to standard algorithm, these 3 problems right here are going to be very important to us. And we'll talk about them later. Right now, let's do the area model. When you multiply, put your numbers toward the top because there might be some addition you need to do within the area model. If you can't add a cross in your head. Okay, so a couple options would be to put the 24 plus the 120 and then add it to the 3,000. Now there's basically 3 ways you can add these up. You can do it mentally, you can do it inside the area model, or you can do it over to the side or on scratch paper. Whatever works best for you. So my first answer is 3,144. 3 times 5?
15.
How many zeros?
3.
3 times 2?
6.
How many zeros?
2.
3 times 4? Okay. So continue on the area model like that. Make sure you add across to get your partial products. So there are my three partial products, okay? Now, we need to add the first two partial products in with the third one. There's a couple strategies for that. You could add all three at once. Or you could add two and then take the answer to that one and add the third number. Whatever works best for you, okay? I'm going to add all three at once right now. So I'll write them all down, line up your digits carefully. Most of the time, mistakes occur when adding because you didn't line them up carefully. Yeah, that's right, isn't it?
It is.
Okay. All right. So we've got, this is our first partial product, this is our second, this is our third, and this is our total answer. Okay? I'm going to erase those little numbers so they don't mess us up. So when we do standard algorithm, let's go across and look at it. Now, this is where last year they came up with the turkey because they said we need to do something to the 3. So that could be the waddle, okay? I've got a better idea, so you stick with my idea on this, okay? For now. So 4 times 6.
24.
So where do I write the 2?
Right there.
In the tens place, right? Are you ready for the standard algorithm? Okay. Why is no one answering me besides Mrs. Lowry? 2 times 6 plus 2 more. Regroup the 1 above the 5, write the 4. 6 times 5?
30.
Plus 1?
31.
Do we have a match?
Yes.
Okay. Now, this is where X's and O's, but there's only 1 0. And the reason there's only 1 0, what's the second problem I'm doing?
524
Times 30. Okay? So, actually it's times 30. We're writing the 0 ahead of time. Remember how Mrs. Dillinger told you, take that 0 off, then put it back on?
Yeah.
We're not going to take it off. We're just going to write it down and forget about it. Okay? So now we have 3 times 4.
12.
Okay, write the 1 in the tens column. 3 times 2
6.
plus 1 more.
7.
3 times 5.
15.
Do we have a match?
Yes.
Okay, now here's where we'll do X,
And O's.
but we have 2 zeros this time.
Put 2 zeros down.
The reason we have 2 zeros, I'm teaching that right now. You're asking a question that I'm talking about right now. The reason we have 2 zeros is because we're taking it times 100. That's the third problem we do. That's why I like the area model, because it separates those 3 problems for us, and we know how many zeros to add. So this time, instead of taking those 2 zeros off, do the math, then put them back on, we're just going to write them down and forget about them. Okay? Now here's my idea. Draw a bell on his collar, and that'll take care of the 3. Okay? So now we have 1 times 4, 1 times 2, and 1 times 5. Does that make sense? 524 times 100? 52,400? Do we have a match?
Yes.
Okay, add it up. Okay, so that's how it's going to change today. Let's take a look at the next problem. How's it different?
Because there's 1,000.
44.
Good. We still only do 3 multiplication problems, okay? But we have a 4-digit number that we're multiplying. So let's talk about the 3 problems we will do is 4,519 times 6.
What?
4,519 times 20. And 4,519 times 300. Okay? So, which number goes on top?
4,000.
Okay, go ahead and break that apart. And how do I write 326 on the side? 6, 20, 300. Okay, go ahead and highlight. Now this is where I'm talking about stamina, boys and girls. We've got a lot of work to do. Let's start with 6 times 4.
24.
How many zeros?
3.
6 times 5.
30.
How many zeros? 2 more, right?
60.
Okay, I would probably, just so I don't mess up, add 60 plus 54 first. So on this one, I chose to do my addition inside the area model. So 27,114. Okay, do you want to try and finish the area model and check it with mine? Okay.
This is this.
pretty big numbers, aren't they? Okay, so on this partial product, I got 1,355,700. Is that what you got?
Yes.
Now we have to add those three partial products. The standard algorithm. And I want you to pay attention to where I regroup, okay? So 9 times 6,
45.
54. Okay. So now we'll do 6 times 1 plus 5.
11.
Okay. So make sure you're regrouping where I am. I'm regrouping above the number I'm getting ready to multiply. 5 times 6
30.
plus 1.
31.
6 times 4
24.
plus 3.
27.
So is that a match? Okay, and I don't know if you remember this or not, but I said don't get your arrows all the way over to the partial products. Okay, so now we have x's and 1, 0. The second problem we're doing is 19 times 20. So how many zeros are on the number 20? That's why we write 1, 0. Okay? You can put the collar on the turtle if that helps you. No, you're done with the 6. So now I have 9 times 2.
18.
So I'll regroup above the 1. Two times 1 plus 1.
30.
Now be careful. See how hard it is to get your numbers lined up when there's a 1 above? Because they don't take up as much room. So then I have 2 times 5. Regroup above the 4. And 2 times 4.
8.
Plus 1. Do we have a match? Okay. So now the third problem I'm doing, I'm multiplying times 300. How many zeros are on the end of 300? 2. So when I write my zeros, how many will I need?
2.
Okay. And I don't know if you remember this or not, but you could draw a bell on that turtle's collar so you know that you're done with the 2. Need to focus, okay? So now I've got 3 times 9. What is it? 27. 3 times 1 plus 2. 3 times 5, 15. Did you notice I regrouped above the 4? 3 times 4
12.
plus 1.
13.
Is that a match? Okay. Did you get the same answer that I did?
Yes.
All right, okay. All right, so the next problem we're going to do, Yasmin, could you get the door, please? It's the same thing pretty much, except they add a 0 in. So you're going to see a lot of the same problems over again, okay? Instead of 4,519, we've got 4,000 plus 500 plus 9, okay? Whoops, 4,000. So 4,000 plus 500 plus 9, because there's no reason to just put a 0 in one column. What your answer would always be 0, right?
Yeah.
Okay. So I'm going to be doing 3 partial products again. The first one will be times 6. The second one will be times 20. and the third one will be times 300. So make sure you're highlighting. And then you do the area model, check it with mine. Wait for me on the standard algorithm because I want to talk you through what we do with the zero, okay? Okay, so you're working your area model, checking it with mine. And thank you for not copying mine. Thank you for just double checking your answers. So when you do the standard algorithm, 0 on the top changes things just a little bit. So I want to talk you through it. Go ahead and put your book away, Tegan. Thank you. Must be a pretty good one. So when I do 9 times 6, what's the answer? So write the 5 above the 0 and let's see what happens. Because eventually this will be a little shortcut for you. Okay, move over to the standard algorithm now. Okay.
I just had to put it.
Okay, because I don't want you to miss what I'm going to say. So eyes up here. When I multiply 6 times 0, I'm going to end up with 0. Okay? So technically, I don't even have to write the 5 up there. I can just write it beside. If you see the 0 coming, you don't actually have to regroup it, the 5. You see what I'm saying? Mm-hmm. You can. There's no rule against it. Now when I do 5 times 6, I have to regroup my 3 way over on top of the 4. And then 6 times 4 plus 3. Okay, my second partial product, I'm multiplying times what number? 20. So I need 1 0. X is an O. Okay. So now same thing again, 9 times 2, what is it?
18.
18. I can write the 1 up here, or I can just go ahead and write 18 because I see the 0 coming. Does that make sense?
Yeah.
Oh, I forgot. You can draw the collar if you want, if that helps. Then I have to skip over to 5 times 2. What is it?
10.
10. Then regroup the 1 on top of the 4. 2 times 4 is 8. Add 1 more. Do I have another match? Okay. So you can draw the bell on your collar. X's. And what am I multiplying by this time?
3.
300. So how many zeros will I need?
2.
2. Okay, same thing again. 3 times 9, what is it?
27.
So I can write the 2, but I don't have to do any multiplying in the next column. Then 3 times 5, 15. Regroup the 1 above the 4. 3 times 4, 12, plus 1. Now, did you notice I don't put any commas in this standard algorithm?
It just confuses
It will confuse you. Don't put commas in your standard algorithm until the very final product. Oops, what did I do wrong?
That's what I got too. Wait. No.
This is wrong.
Yeah, that's what
I found a mistake, didn't I? 7 plus 1 is 8, Mrs. Lewis.
I did that.
I had an answer wrong. No, it's not,
Because there's.
because I had to regroup.
Yeah.
So what did I do wrong here?
You forgot.
I forgot to regroup. Goodness.
I thought I was wrong.
No, it's me. All right. How's that look? Do you have a match with my
Yes.
answer? Okay. So the next slide, we're going to take out another number and replace it with the 0. Okay? So take a look at this problem. Now, I kind of helped you with the area model already. All right? So you know that on this one, you're just going to do 300 plus 6.
Yep.
And 4,509. So you'll see some of the same problems again. So do your area model, check it with mine. Wait for me on the standard algorithm, please. On the standard algorithm, we need to look at how many partial products we're going to have and plan ahead for this. So if you look over on the side of the area model, Tegan, you'll see that I have how many numbers I'm multiplying by? A 6 and a 300, right? So that means I only have 2 partial products. So the first row multiplication will not have a 0 on the end. The second row of multiplication, how many zeros will we put on the end? 2. So we're skipping from no zeros to 2 zeros. And you need to focus on what you have over here on your area model, and that will help you. You can also look at the place value of the 3. You know it's in the hundreds place, so you're going to need 2 zeros. Okay? So this is 9 times 6. What is it?
54.
I think I'm just going to write 54. Because I know if I write my 5 up there, I'm going to copy it down anyway. Okay? So now I'm ready for 6 times 5. 6 times 4 plus 3.
27.
Do we have a match?
Yeah.
Okay. So now, cross off your 3. Write how many zeros? 2. Why are we writing 2 zeros?
Because it's in the
The 3 is in the hundreds place. We're actually skipping that 0, aren't we? Last year, I think you wrote 4 zeros down. And then you added it up. We're just skipping that row. There's no reason to take the time to write a whole row of zeros when you're in 5th grade. See what I'm saying? And you know what your partial products are multiplied by. A 6 and a 300. How many zeros are on 300? That's why I write 2. So 3 times 9. I'm just going to write it. I'm not regrouping that 2. I know it's above the 0. I know I just get to write a 2. 5 times 3. 4 times 3 plus 1 more. How's that partial product? Okay. All right. So what do you think of zeros? I sort of like them.
Yeah.
I really like them on the bottom number.
It feels like they make them
Yeah.
less regrouped.
Okay, so we will start the problem set.